Okay, let's have a quick read of this question 13. A block with mass 2 kg is pulled from rest up a slope. I'm just going to put up a smooth slope, okay, inclined at 20 degrees to the horizontal by a string with tension T maintained at 30 degrees to the horizontal. After 5 seconds, the block has moved 1 meter along the slope. Calculate T. The block is allowed to come to a rest again, then the tension is increased, so the block is about to lift off the slope. Calculate the minimum tension needed to achieve this. Okay, so let's first of all draw a diagram. So we've got this diagram. We can say that from here, there's a horizontal. So block smooth inclined at 20, so we've got this inclined at 20. Okay, so we've got this block. I'm just going to call it a particle. So that's coming down here with a weight of 2g. Okay, and this is being pulled by a string maintained at 30 degrees to the horizontal. So if that's the particle, that string to the particle, if that was there, well, we know that's 20, so this will have a further 10 degrees here. Okay, so that's the tension of that, because 20, that will be 20, which is corresponding to that angle here. But from this slope, that will be 10 degrees up from there to there. Okay, so let's just have a look at how far. What I'm going to do is call that a different color. So this here is 10 degrees to this slope. Okay. Right. Okay. Right, so let's have a look. So that's there. If we go and draw something like this with the triangle, that will be 20. So coming down here, that will be 2g sine 20. Okay, now we don't need to worry about the contact force here because we've been told the slope is smooth, so don't worry about that. And what we know that this is being pulled. Now if we, because we are working in line with this slope, so in line with this slope, we'll go and draw a right angle to here. We know that it's being pulled upwards. It's going like that up along here. So that's going to be by 10. No, not 10. The tension T, and that's cos 10 degrees. And it's also, because it goes like that, it's being pulled that way too by T sine 10 degrees. Okay, just be careful on that one. So it's going along the slope 10 that way, and on here it's going 10 with sine and 10 with cos that way. Okay, right, so at the moment we just need to know what's going along, the action going along here. So what's going along here is being pulled along with this T. So I'm going to use Newton's second law, which is force equals mass times acceleration. So the resultant force here, that's being pulled with the force of T cos 10 degrees, okay, up the slope. Now what's going against it is the weight down the slope, which will be minus this figure here, 2g sine 20. And that's going to be moving with the action of mass times acceleration. The mass of that particle is 2 kilograms, so it's 2a. Okay, so we've got that happening. Now if we've got that happening, if I rearrange this, now before I rearrange this, acceleration, we need to find acceleration. So we need to find acceleration, and we need to find the tension. So there's two unknowns here. Now when there's two unknowns, we've been given some other clues. We've been told that it's released. Is it released from rest? Yep. So we know we can start using SOVAT here. We've been told that so rest initial was 0, so it's at rest. We've also been told after 5 seconds T is 5, and it's moved, so displacement is 1, and we need to find A. Just trying to get it from there. Okay, so because this is a resultant force, this force will be constant, which means acceleration will be constant, and therefore we can use SOVAT here. So if we got those components, we know we can use the S equals ut plus half at squared. Okay, so S would equal, sorry, should have just said S is equal to 1. Now u is 0, u times anything will be 0, so that will go, and here you'll get half times A times T is 5, so that will be 20, T squared, 5 squared will be 25. So if we rearrange this, we've got 25 over 2, therefore A is going to equal 2 over 25, okay, which is 0.08 meters per second Now we've got that, we can rearrange this, so we can say T cos 10 degrees is going to equal, take that to the other side, so we've got 2 times the acceleration, which we know is 0.08, plus 2g, which is g is 9.8 times sine 20, all over, now I'm going to take this to the other side, which is going to be cos 10 degrees. So that's gone. So therefore tension will equal, now if we put that in our calculator, you get tension to be 6.97. Okay, 2 free single figures. Now keep this answer in your calculator, because we might need it later, okay, to get the exact value. Now the next part, it tells you the block is allowed to come to a rest. So let's say it's come to a rest now, then the tension is increased so that the block is about to lift off the stop. Calculate the minimum tension needed to achieve this. Okay, so the minimum tension needed to achieve this, let's just have a look here. So if that's going to be lifted, if that tension is going to be strong enough to lift that off there, first of all we've got, I'm going to do this in a different color, a different question, so part B. So we've got this contact force happening here, okay, of this block, and we've got to call that, because we've got to call that block, I'm going to call that RB, the block. Now this is also tension is acting up here, okay, so what I've got the reaction of the block plus, because this tension is going up with this, okay, so I've got T sine 10 degrees. So that's been, because that earlier on I said this tension acts along the slope and then perpendicular to it, okay, so you need to get each component there. So once we've got those, we can say that is the case. So that's being lifted. Now if that's going that way, what is going against that is the weight coming down on here, which here, if you look down here, weight opposing that, because that's cosine, that's going to be 2g, that's the hypotenuse of this right angle, cos 20. So that's going to equal 2g cos 20 degrees. Okay, so now if we need that, we need to work out what is this going to be. Now in order for it to lift up, the minimum tension, when it lifts up, there's no contact force. So if I say about, oops, can't spell, about to lift, that will imply the contact force between that slope and the block will go to 0. Okay, because there's not going to be any contacts. So that goes to 0. You'll just get that tension equals to, I'm going to divide it, well, I might as well put the whole thing, tension sine 10 degrees equals 2g cos 20, because that's gone to 0. So the tension needed, the minimum tension, so I'm going to say tension is going to be greater than equal to, for this to happen. Okay, so you get the minimum tension. We can find out the minimum tension, because obviously if that's really high, it'll lift up anyway, so we need to find what is the minimum to cause this. So that will be 2g cos 20 shared by sine 10. So that's going to give me 106.1 newtons, and to free center figures that is 106 newtons. And note, tension is going to be greater than or equal to that, but that's going to be the minimum force required to make that go to 0, to make it lift. Okay, obviously that could be a lot higher, which will just lift it no problem. Okay.